For today's video, you'll need your science book, your paper that you've already been taking notes on, pencil and your two colored pens or colored pencils, and you'll probably need another sheet of paper because we're probably going to run out of room down here. Okay, we're starting here in this section with the year and the seasons. So right here we're going to skip a line and then we're going to do year, capital Y-E-A-R, and A-N-D, seasons, capital S-E-A-S-O-N-S. Switch to our pencil, and here we go. In addition to rotating about its axis, Earth travels around the Sun in a nearly circular orbit. It takes Earth 1 year to complete one revolution, or orbit around the Sun. Ordinary calendars show that 1 year lasts a total of 365 days. However, the actual time for a revolution is longer by exactly 5 hours, 48 minutes, and 46 seconds. This adds almost 6 hours to each year. Over 4 years, that adds almost 24 hours, or 1 day. Okay, so that 5 hours, it's almost 6 hours a year. 6, 12, 18, 24. 6 times 4 is 24 hours. That's why every 4 years you get an extra day. So to keep calendars in line with Earth's movement around the Sun, 1 day is added to the calendar every 4 years. That day is February 29th. The extra long years are called leap years. Okay, we already have the word revolution in our vocabulary. Let's go ahead and put over here 1 orbit, O-R-B-I-T, equals 1 year, Y-R abbreviation. Squiggle, 365 days, D-A-Y-S. But the at symbol, so a letter A and then circle it, which is like at, or it can also mean every. Every 4 years, Y-R, equals 1 extra, E-X-T-R-A, day, D-A-Y. And then we're going to squeeze it in real tiny, leap, L-E-A-P, year, Y-E-A-R. That's why we have a leap year every 4 years. All right, let's keep going. Why does Earth have seasons? As you learned, Earth rotates about its axis. So it's rotating or spinning around that axis. The axis is not vertical, but tilted about 23.5 degrees with respect to the vertical. So that means that instead of being straight up and down, it's tilted about 23.5 degrees. Because of the tilt, each pole is oriented either toward or away from the Sun, depending on Earth's position in its orbit. This is why Earth has seasons. So, if you look at this picture over here, for us in North America, which is up here at the top, this is winter because we are tilted away. And when it comes around to the side, it's kind of even around the entire area, so that's spring. And then when it's tilted this way, it gets hotter because we are closer, so that's our summer. And then when you get all the way around to here, that's fall, and it starts getting colder again as we start to tilt further away and as we orbit around the Sun. So that tilt on the axis makes us either tilt away in the winter or tilt toward in the summer as the year goes on. Okay, so let's write that over here. Tilt, T-I-L-T, arrow, seasons, S-E-A-S-O-N-S. So the Earth's tilt is what causes us to have seasons. Let's say toward, T-O-W-A-R-D, equals summer, capital S-U-M-M-E-R. And then away, A-W-A-Y, equals winter, capital W-I-N-T-E-R. So when we're tilted toward the Sun, it's summer, but when we're tilted away, it's winter. In the middle of the calendar year, the northern hemisphere tilts toward the Sun. Hey, that sounds like summer. As a result, the Sun climbs higher in the sky and the days are longer. The sun's rays strike the ground more directly, resulting in the warmer days of spring and summer. Oh, okay. So toward equals summer. Let's put hotter, Hotter, and let's put longer days, Longer, days, Days. So I already know what we're going to put for winter, colder, Colder, and shorter days, Shorter, days, Days. Okay, let's keep reading. During the rest of the year, the northern hemisphere tilts away from the sun. Sounds like winter. The sun is lower in the sky, stays above the horizon for fewer hours. The sun's rays are angled as they strike the ground, which spreads out the sunlight. The northern hemisphere experiences cooler days of fall and winter. So where it said that the sun stays above the horizon for fewer hours, that means shorter days. Okay, let's look at the picture. Earth's seasons in the northern hemisphere. So these are the seasons we would have on these. But if you go down to South America, like Brazil and Argentina, or if you go to Australia, their seasons are opposite of us. When we are tilted away in the winter and cold, they are tilted toward, and it's actually their summer. Come over here. When we, on the north, are tilted toward and hotter, they, on the south, are actually tilted away and colder. Okay, on a December day, Los Angeles has less than 10 hours of daylight. The winter sun is low in the sky. So that's right there. South of the equator, Buenos Aires has more than 14 hours of daylight. The summer sun is high in the sky. So when it's our winter, it's actually their summer. Okay, next page. Earth's climates. Red pen. Look over here. Earth's, capital EARTH'S. Climates, capital CLIMATES. Switch back to the pencil. The shape of Earth's orbit around the sun, the wobble and angle of the Earth's axis, and Earth's rotational speed vary very slowly with time. So what that means is moving around in the orbit changes just a little tiny bit as the year goes on. It can get a little bit faster, a little bit slower, but it kind of evens out. Wobble means that even though the Earth is spinning, the axis kind of like wobbles a little bit. It doesn't always stay at that perfectly same angle. So it varies or it changes just a little bit as time goes on. As a result, the amount of solar energy Earth receives varies slowly. Therefore, Earth's climates do not change much over hundreds of years. This means that weather patterns and temperature ranges can be predicted fairly accurately. So, the tilt is pretty steady and doesn't change very much. How fast we revolve or rotate does not change very much. And then how fast we orbit does not change very much. So that means the amount of sun that we get does not change very much. Okay, so let's use this part right here. The energy that the Earth receives varies slowly. In other words, energy, ENERGY, squiggle, steady, SDEADY, comma, little, LITTLE, change, CHANGE. So the amount of energy that the Earth gets is pretty steady. There is very little change. That means weather is predictable. Weather, WEATHER, predictable, PREDICTABLE. Now we're going to learn that climate and weather are related, but they are not the same thing. For example, people living in Chicago, Illinois, can rely on average temperatures about -6 degrees Celsius or 22 degrees Fahrenheit. That's basically freezing cold every January. Oh yeah, that makes sense. Winter in Chicago, very cold. People living east or west of Chicago can expect similar low temperatures. So, all the cities that are way high up here in the north of America, up there where Chicago is, can expect to be pretty cold. Yet the weather changes when you head south from Chicago. As you move through St. Louis, Memphis, and Houston, the temperatures increase. So St. Louis is in the middle of the country in Missouri, Memphis is in Tennessee, and Houston is all the way down there in Texas, where it's really hot and humid and warm most of the year. Houston's average January temperature is a warm 11 degrees Celsius, 52 degrees Fahrenheit. This trend is present during other seasons, too. Okay, those are specific examples to show us how the further north you are, the colder you are in general, and the further south you are, the warmer you are in general, which is back to this energy is pretty steady, there's very little change, so that makes our weather predictable. What causes this trend? As you move south through the United States, you move closer to the equator. Places closer to the equator receive more solar radiation and thus are warmer. Okay, so let's write equator, E-Q-U-A-T-O-R, greater than poles, P-O-L-E-S. And let's put underneath that energy, E-N-E-R-G-Y. So in general, when you're at the equator, you're receiving more energy than you are at the poles. So that means that the equator is warmer, W-A-R-M-E-R, and the poles are colder, C-O-L-D-E-R. Okay, if we look at the little globe here, Chicago is way up here in the north, so it's generally going to be colder near the poles. And Los Angeles is further south towards Mexico, and so is Houston, Texas. They are closer to the equator, so they're going to generally be warmer because they're getting a little more energy. As you will learn, many factors affect temperature and climate. For example, oceans tend to moderate the temperature of coastal areas. This is why California cities have warmer winter weather than places farther inland. That is very important. If you have huge bodies of water, your temperatures don't get super hot or super cold and fluctuate a lot. They stay pretty steady. Like if you ever go to the coast or go to the beach, you'll notice that even in the winter, it's not really freezing cold. And even in the summer, it's not blazing hot. Okay, so oceans moderate temperature. Let's say big bodies of water. So, large, L-A-R-G-E, water, W-A-T-E-R, bodies, B-O-D-I-E-S, arrow, moderate, M-O-D-E-R-A-T-E, and below that, temperatures, T-E-M-P-E-R-A-T-U-R-E-S. So large bodies of water help to moderate temperatures. Okay, or moderate also means steady, S-T-E-A-D-Y. And let's put that in parentheses so we know that it goes with the word moderate. Or moderate, sorry. Earth enjoys relatively stable, mostly moderate climates. This makes Earth a wonderful place to live for a huge variety of living things, including you. So, all that stuff we've talked about, the steady orbit, the steady rotation, and the steady tilt. So, therefore, a steady amount of energy leads to stable temperatures, stable weather, and stable climates. Okay. Cause and effect. What causes the climates on Earth to stay about the same year after year? Well, I feel like now we can answer that, right? We can say that the energy coming from the sun is pretty steady and that there's very little change. We can talk about how the orbit around the sun pretty much stays the same and circular. We can talk about how the revolution on the Earth's axis is pretty steady and constant, and how it tilts a little bit, but that tilt stays the same. So all of that information makes the weather predictable, helps us know that the equator is always going to be a little bit warmer, the poles are always going to be a little bit colder. And then we also know that if we have really large bodies of water, like oceans or lakes, that's going to help moderate temperatures. Underneath large water bodies, let's put oceans, oceans/lakes, LAKES. Okay, well, because of these paragraphs of the specific examples and not having to write stuff down, we actually ended up fitting everything on our piece of paper. So we didn't need our new piece of paper yet, but tomorrow we will. Good job persevering, growth mindset, and roar Wildcats!